Professor's cube. Description of this cube. Solution is much the same as 3 times 3 times 3 cube, except additional, and relatively simple, algorithms are required to unscramble the centerpieces and edges. Megaminx. Description of this cube. 12-sided polyhedron puzzle similar to Rubik's Cube in operation and solution. Pyraminx. Description of this cube. Tetrahedral-shaped puzzle with axes on the corners and trivial tips. It was invented in 1970 by Uwe Meffert. Impossible. Description of this cube. Rounded icosahedron puzzle similar to Pocket Cube in operation and solution. Scube. Description of this cube. Similar to the original Rubik's Cube, the scube differs in that its 4 axes of rotation pass through the corners of the cube rather than the centers of the faces. As a result, it is a deep-cut puzzle in which each twist scrambles all 6 faces. V-cube. Description of this cube. Panagiotis Verdi holds a patent to a method which is said to be able to make cubes up to 11 times 11 times 11. He has fully working products for 2 times 2 times 2 to 9 times 9 times 9 cubes. Gigaminx. Description of this cube. Megaminx variants with multiple layers per face. The Gigaminx has 2 layers per face, for a total of 5 layers per edge. The Teraminx has 3 layers per face, 7 layers per edge. And the Petaminx has 4 layers per face, 9 layers per edge. Square 1. Description of this cube. A variation on the original Rubik's Cube where it can be turned in such a manner as to distort the cubical shape of the puzzle. The square one consists of 3 layers. The upper and lower layers contain kite and triangular pieces. The middle layer contains 2 trapezoid pieces, which together may form an irregular hexagon or a square. Square 1 is an example of another very large class of puzzle, cuboid puzzles which have cubies that are not themselves all cuboid. Barrel cube. Description of this cube. Mechanically identical to the 3 times 3 times 3 cube. It does, however, have an interesting difference in its solution. The vertical corner columns are different colors to the faces and do not match the colors of the vertical face columns. The corner columns can therefore be placed in any corner. On the face of it, this makes the solution easier. However, odd combinations of corner columns cannot be achieved by legal moves. The solver may unwittingly attempt an odd combination solution, but will not be aware of this until the last few pieces. Cube diamond. Description of this cube. An octahedral variation on the scube. It is a deep-cut puzzle very similar to the scube and is a dual polyhedron transformation. Pyramorphics. Description of this cube. Edge-turning tetrahedron-shaped puzzle with a 2 times 2 times 2 cube mechanism. Pocket cube. Description of this cube. Simpler to solve than the standard cube in that only the algorithms for the corner pieces are required. It is nevertheless surprisingly non-trivial to solve. Megaminx. Description of this cube. 12-sided polyhedron puzzle similar to Rubik's Cube in operation and solution. Gear cube. Description of this cube. This twisty puzzle was invented by Oscar van Deventer. Edge pieces are gears that turn when faces turn and force opposite faces to turn together. Despite its appearance, it is considered easier than the Rubik's Cube. Pyraminx crystal. Description of this cube. A dodecahedron cut into 20 corner pieces and 30 edge pieces. It is similar to the Megaminx, but is deeper cut, giving edges that behave differently from the Megaminx's edges when twisted. Cube Ultimate. Description of this cube. While appearing more difficult than the Skewed Diamond, it is functionally very similar to the Skewed and Skewed Diamond. The puzzle is cut in a different manner, but the same solutions can be used to solve it by identifying what pieces are equivalent. Because faces of the Skewed Diamond correspond to corners of the Cube Ultimate, an additional constraint on the orientation of these pieces appears. Any Skewed Diamond solution thus requires a few additions in order to solve the Cube Ultimate.